Okay, 3 problems up on the board. Got to figure out what their Lewis structures are going to look like. this what we're coming up with for the first one?
Wait, mister,
What?
what are the extra two? Are there three?
Is there 3 on xenon?
Yeah. Then are we coming up with this for IF5? Then are we coming up with this for SO3? On this auction?
Yeah.
I took them away so I could make a double bond.
Oh,
Okay? Does anybody have any questions with any of the 3 examples? Else?
The first one.
First one.
I had 22 electrons. So I didn't get 3 on xenon, or 3 pairs.
Okay, so let's walk through this real quickly. So yeah, everyone came up with 22 electrons for XeBr2, right? Okay. So let's go back to the beginning. All right, so after your skeleton structure, you said xenon, central atom, single bond to each of the bromines, right? So how many electrons have we used up so far? 4. That takes us down to 18 electrons. Then we gotta complete the octet for our outer atoms, so each of them is going to get 6 electrons, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that gives us 6 remaining. Now, bromines are happy. Xenon right now has 4, but what the rule is anything that's left over, any electrons left over, we have to put them as lone pairs on the central atom. So in this case, xenon is going to have that expanded octet to it, and it's going to have more than 8 electrons going to it. So 3 lone pairs on xenon. Okay? Other questions?
I have no idea how you got that on S.
Okay. So, once again, let's start at the beginning. Let's just see how many electrons we come up with, okay? Did you come up with 24 electrons?
No.
Well, how many did you come up with?
I came up with 20. I accidentally counted wrong.
Ah,
Never mind.
okay.
That makes
So,
sense now.
that's where that's going to happen. Does anybody else need me to continue with the third one, SO3? Yes? Okay. Alright, so skeleton structure, sulfur as our central atom, right? Single bond to each of the oxygens. We used up 6, so we have 18 remaining. What are we going to do with these 18? Lone pairs around our oxygen atoms, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Down to 0. Then ask, is everybody happy? The answer is no. Who's not happy? Sulfur. So what we're going to have to do off of one of the oxygen atoms, doesn't matter which one we take. No. Doesn't matter which lone pair we take. No. We just need to take a lone pair off one of the oxygen atoms so that those can be shared between the oxygen and sulfur. So that sulfur reaches the 8. Okay? Any other questions?
Then you get Then you get 20.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
Each line is worth 2.
Remember, a single bond, 2 electrons in it? Okay. Any other questions right now? Nope. What we're going to be doing today is we're just going to continue on because there's a couple more things I need to show you with Lewis structures. Then on Monday I'm going to have an assignment for you in which you're just going to complete the first part. And the first part is just working on drawing out the Lewis structures. Okay? First part today is, let's kind of look at a structure in which we really got to figure out what's going to be our central atom. Okay, so first thing, go ahead and figure out how many electrons we're working with. Are we coming up with 24 electrons? Okay. So now, trying to figure out what's going to be our central atom. Well, can we kind of reduce it down to 2 possibilities? What are going to be our 2 possibilities for this one? Carbon and oxygen, because we have one of each one, right? All right, so which one is going to be definite central atom, which one is not? Well, what we're going to do is, and what we should be doing, the element that's going to be your central atom, a lot of times it's going to be the element that has more unpaired electrons. Okay, so between carbon and oxygen, which one has more unpaired electrons? Carbon, because carbon has how many valence electrons to it? 4. And guess what? All 4 of them are unpaired. Okay? So carbon's our central atom, then a single bond each of the other atoms. Go ahead, finish this one up. Okay, so did we at least get to this point?
Yep.
All right. So is everybody happy? No, who's not happy? Carbon. So this particular situation, there is one outer atom that we definitely need to take the lone pairs off of so we can make a double bond to it. Which of the outer atoms are we going to take the lone pair off of? Oxygen, because chlorines are a halogen. Halogens will only have
One.
single bond to it. So in this instance, yeah, from the oxygen, we're going to take a lone pair off of it so we can make that double bond between the oxygen and the carbon. Questions? Any kind of questions? No? Try this one. off.
Yeah, that's what I did, but then like it's not happening. So that's why I double bonded everyone. Yeah, like I yeah.
If you watch the video, everybody else, when you
Sammy, you say you double bonded on this
more
one?
than 8.
On both, like
That's
both?
it.
No, it's only one. I think.
That's what I did.
I think this is right. You got any?
Are we coming up with 8 electrons?
18.
18.
Or 18, sorry.
18.
Been a long day. Alright, what's going to be our essential atom? Nitrogen, oxygen, or fluorine? Nitrogen, because it has more unpaired electrons, right? So if we go ahead and draw our skeleton structure, single bond to the fluorine and oxygen, used up 4, 14 remaining. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we're down to 2. Those remaining 2, where are we going to put them at? Nitrogen. Now we're down to 0. Is everybody happy? No. Nitrogen. So we need to make a double bond, right? So which element are we going to take the lone pair off of so that we can make a double bond?
Oxygen.
Oxygen. So how many people came up with this?
Any that are in here
Okay.
can't have two.
But then it only has 6 going to it.
It has 8.
So then, since it's
Because of
highlighted
the
red,
lone pair on top.
No, just this row, just the 7th row.
1, 2, 3, 4, 5, 6, 7, 8.
can't have.
Oxygen has 8. 1, 2,
Anyone else
3,
has to
4,
have it.
5, 6, 7, 8.
Anyone else has to have.
Anyone else can't have it, but
Okay.
else can't.
Questions? Any questions? No? Okay, so now, kind of go along with this, let's look at another item that we're really going to be looking at next couple chapters.
Yeah. This thing is not very
We're going to be looking at polyatomic ions. Polyatomic. What does poly mean? Many. Atomic. Atoms. Okay, ions. What do ions have?
Positive or negative charge.
They have a charge. Okay, so with polyatomic ions, we have covalently bonded atoms with an overall charge. When we're trying to figure out the Lewis structure for polyatomic ions, there's something we have to do with the number of electrons, the addition. Okay. After we figure out how many electrons we have, it's the same thing that we've been doing so far with figuring out Lewis structures. Okay. So let's look at our first example. NO3 with a -1 charge. So right now, just figure out how many electrons we're going to have and stop. Are coming up with 23. And if you kind of remember when we talked about this on Tuesday, the number of electrons needs to be an even number. Okay, so with polyatomic ions, we have a charge, right? That charge tells us whether we need to add in more electrons or take away some electrons. So it has a -1 charge. And what kind of charge do electrons have? Negative. So in this case, we're going to add in one more electron to it. All right, so for this one, we have 24 electrons to work with. Go ahead and figure out what the Lewis structure is going to be.
That's good. I don't change it. I hate you for the plan. Use it. It's like horrible.
Is this what we're coming up with for our structure?
Yeah.
Okay, now there is one more thing that we need to do. Nothing really hard. Since the overall structure has a charge to it, we need to show that that charge is with it. And the way that we do that is we put the Lewis structure inside brackets, and we put the charge on the outside of the brackets.
If it's positive, is it gonna have a positive charge?
Yeah, if it has a positive charge, we'd have a positive charge with it. Now, if our polyatomic ion had a positive charge to it, what would we do to the number of electrons in that situation? You take one away, or take two away, depending upon what kind of charge number it would have. Okay? Questions? Any kind of questions? No? All right. Let me give you one, see if you can figure it out on your own. Okay? Which one should I give you?
An easy one.
An easy one?
Yeah. I shower like her. Or easy.
No, easy.
Make it hard. Easy.
Now hopefully you're kind of seeing that this is kind of easy to do a little bit. All right, so since this has a -2 charge to it, what are we going to be doing with the number of electrons? Adding 2 to it, yes.
Cool, are you?
Oh.
Is that right?
Fuck yeah.
Or you said, I don't know.
No, no.
It's kind of funny.
And they haven't told me the price yet.
They haven't?
Huh.
Maybe they won't make you pay for it.
Hope not. So wait, we add the 2 to it or the 3?
Well, it'd be -2, so you subtract 2.
Oh, you subtract?
No, you add.
You haven't done all these
I need to put brackets, but
Yeah. Wait. Hold
I know, I didn't think I was right.
on. Let me see it.
Okay. I don't have, I'm missing an extra there, so.
Well, you see how it says 2 negative?
Yeah.
You're,
So we got the
you have to add 2.
Yeah,
To make it 24.
yeah, because if we didn't do that, then we wouldn't have enough electrons really to have this ion even be functional.
I honestly think this is pretty easy.
yeah, if I knew what these were.
It's not that hard, it's just the same.
What is the 2?
Dude, that nap sounds good. I've taken a nap like every day this week. It's not good.
Go home sounds good. What do you mean nap?
Are we
I need to
coming
go
up
nap
with-
at 5:30 at night.
This,
No, like,
off one of the auctions, we should have a double bond, the other 2 auctions, single bond.
Yeah.
And then just picture brackets and -2 charge on the around it.
Yep.
Questions?
What if I have 4 going to 2 of them? Like, what if okay, the one that had 4 in the first place.
Let's put the cell phones away, please, ladies and gentlemen. Off the table.
So I have 4 for that one. And
For
then
what?
for the awesome. For that one also.
You mean this one?
Yeah. And then I put a double bond to a different. And I erased one of my things.
Let me come back and see what you're talking about, okay? Let's try one more for good measure.
You think you should do this thing? That's almost hard now.
Damn, right, my hair. Here we go. Follow them around the classroom.
Okay, so I have this one. But this one's the carbon. So I'll put a couple of this one. Oh, yeah, man. Okay, yeah.
That's where.
Okay, yeah. All right, thank you.
Hey, do you have to add anything to them?
Yeah, you got one, because you got the negative.
Which one you put in the middle, C?
Mm-hmm.
Or does it matter which one you put in the middle?
It has to be C because, so if you look over here, whichever one's the smallest number, you gotta put in the middle.
Oh, I see.
Why did you look at the pattern?
Yeah.
Shoot. Can you take it away from the end? Yeah. Same piece of crap.
There we go.
SCN.
Yeah, because it kind of looks like a in the glare. Not as straight as. Alright, click it. You can't get it though. Try to fix it.
I don't want to forget it. Yeah, I don't know.
That's screw it.
There we go. No.
Yesterday in 8th grade, everyone came up with the same drawing. But today,
Beyond both of them.
so,
Here, just go like this. Pull her up. As long as the sand's like not even. This seems like this thing drag around. Rip the book out.
are we coming up with 16 electrons? Okay. Which one's our central atom? Carbon? Did we at least get to this point? And we saw that carbon only has 4. We need 4 more, right?
Yes.
How many people did this? You took a lone pair off of sulfur to make a double bond. And in this setup right now, carbon now has 6. Sulfur has 8. Nitrogen has 8. Then anybody go over to nitrogen, take a lone pair off of it, make a double bond between carbon and nitrogen?
I did.
Okay, how many people did that? Just show of hands. Okay,
I thought it was gonna be a little.
that is correct. Now, did anybody do this?
A triple bond. I was thinking about
Did anybody make a triple bond between nitrogen and carbon and a single bond to sulfur? Guess what? That is also correct. Did anybody do this?
Call me cameraman.
Did anybody have a triple bond between sulfur and carbon and a single bond to nitrogen? Guess what? That is correct as well. All 3 of these following the octet rule. Does everybody have 8 electrons in this situation? Yeah, so following the octet rule, all 3 of these are correct. Now, when we have more than one possible way of drawing out the Lewis structure, we have what is called resonance. Okay. So, resonance, more than one way of drawing the Lewis structure, or a compound slash polyatomic ion. With these 3 different ways of drawing for our polyatomic ion up here, one happens more often than the other 2. Now in here we're not going to really worry about which one's going to be the more prominent one. But with this one I always try to see if anyone does come up with this structure or this structure. Because a lot of times people come up with this one, which like I said is fine. Okay, because you look at it and you think, okay, well, when we did carbon dioxide, CO2, we took a lone pair off of each of the oxygens and we had a double bond going from carbon to both the oxygens. Okay? You kind of see the same way with this one? But we could also have done this. Or this. Okay? Questions? Any kind of questions with polyatomic ions? No? Well, let's go into looking at compounds. I guess you can kind of say they're going to be just a little bit more complex than what we've been doing so far. But these, what we're going to do is we really don't have a central atom to look at.
Look at it.
Alright, C2H4. Just like what we've been doing so far, figure out how many electrons we're working with.
Got him jacked up. There we go. Kind of. There we go. Much better.
Alright.
Oh my god.
Yeah, come on.
Are we coming up with 12 electrons? Okay. What's kind of going through your heads right now? How should we kind of start figuring out how to set up this Lewis structure? Hunter?
This is C, there's 2 C's and the H can only be a 1 bond. You'll have 2 C's as your main instead of 1.
2 C's as your main? What do you mean by 2 C's as your main?
Like C, C, and then you have 1 H going to the C. Yeah.
Like that? We need a little bit more than just that.
So we'll have an H, 2 H's going to 1 C. And then there's, yeah, like that, and then the same on the other. And then you have 1 bond going in the middle of the C's.
Will it work? Yeah. Alright, so let's kind of go off this one. How many electrons have we used up so
I don't
far?
like that. Is that really how you do that?
That's right.
That's one way of saying it. Now, what Hunter said, yeah, is true. Hydrogens will only have single bonds going to them, right? Will hydrogen ever be a central atom? No. So we know that the hydrogens are going to be our outer atoms. We have 2 carbon atoms, right? We said that the element with more unpaired electrons will be our central atom in this situation. So if we just draw a bond between the 2 carbon atoms, Hunter said this and everything, he was right. Let me just kind of reword it a little bit more, okay? Now, the 4 hydrogens, split them up evenly.
Following students need to please come to the front lobby with your things. Lily Eldridge, Paula Carrero, Logan Pike, Emily Brunker, Paige Gauk, Cole Stephen, Timothy Peters, Kenzie Ogden, Shedley Berkheimer, Casey Love, Laney Brunker, Emily Brunker, Chloe Cliff.
There goes my
We'll watch the last part of this on the video, okay?
There goes my
All right, so now, we look at our skeleton structure. How many electrons have we used up so far? 10. Now we have 2 remaining, right? Okay. Hydrogen is happy with how many electrons? 2. Carbon on the left, how many electrons does it have going to it? 6.
You can bond the double bond to a carbon.
Well, hold on. Because carbon on the left has 3 single bonds to it, right? Everybody see that? 1, 2, 3. Okay, carbon on the right, same thing. 6 electrons. So these remaining 2, let's share between the carbon atoms by making a double bond. Now we're down to 0, and is everybody happy?
Yeah.
Yes. Okay. Questions? Any kind of questions? No? Let's look at another one.
Oh, this moves much easier since you did that. Really? That's fine. Yeah. Jesus.
Okay, figure out how many electrons we're working with total. Last time I'm going to say this, put your cell phones away. Are we coming up with 44 electrons?
What's the highest that you can go with the numbers?
Infinity.
So you could go like
Of the valence electrons on the middle thing? Like, if you put put C as your middle, you have 12 valence electrons on it. If you branch them all off of C.
No, that will never happen.
Okay, so
She was asking how many total valence electrons, right?
yeah.
Yeah, that can,
So you could have up to like.
because some molecules are huge. They just have long carbon chains, and so their masses, or, you know, the number of valence electrons can keep on
Will we
growing.
ever deal with carbon really big like that?
That depends upon you all. All right, so when we have a compound like this, let me show you a kind of simplified way of figuring out how to set it up. What two elements do you think we should kind of look at as our quote-unquote central atoms?
C and N.
Carbon and nitrogen. So let's go ahead and let's draw a bond between carbon and nitrogen. Sometimes, if we look at the chemical formula, it's already telling us what's bonded to what. All right, so if we look at our formula right here, after the carbon we have 3 bromines. Guess where we're going to put those 3 bromines at? On carbon. After the nitrogen we have 2 chlorines. Guess where we're going to put those 2 chlorines at? On nitrogen. Okay. Finish her up.
So do you add all the
2, 4, 6, 8, 10, 12, 14, because you gotta add this twice over here. I think. Not sure.
4, 6, 8, 10, 12, 13? And you get 30.
Hold on, let's see what it does.
Did it just cut out?
No.
I don't know. It has the. It says it's on the
Low
spec.
battery.
Low
Yeah,
battery?
Low battery.
Okay. Go ahead, stop. Hit the record button.